Hey, welcome everybody to another session of the second edition of the Global Dev Week by Encora. I'm so glad to be here. My name is Alexis Flores, part of the community building team of Encora Mexico's team. I'm so glad to be here presenting and introducing this session because it is part of our team members from Colombia. But before to start and introducing to him, let me share with you some announcements. Please remember that you can follow us on the social media appearing on the screen right here. In order to you can be ready to follow the next projects, and we are ready and preparing for you. And also remember to leave a comment or ask questions using the chat, the live chat that we were using through this session, because at the end of this session, Jhon will be reading comments and questions regarding his presentation. Once it's said, let me introduce to Jhon. Jhon is a system engineer with specialization in project management. He has an MBA and extensive experience in leading technology projects. He also has expertise in process design, application architecture, and performance evaluation. Currently, he is a senior software engineer at Encora, working with technologies like Golang, Elasticsearch, and AWS. Recently, he obtained a certification as a solutions architect at AWS. Congrats on that achievement, Jhon. I don't want to spoil the rest of the session because I'm sure that Jhon will share really significant content for all the audience. So Jhon, please welcome to your stage, and I pass the floor to you.
Okay, thank you so much. Welcome to my presentation on designing a highly scalable system on AWS. I'm going to talk from concept to execution. My name is Jhon Quintero. I am glad to be your presenter right now. Okay, our agenda for today is one to talk about a case study. It's a fascinating case study of a content management software. We will deliver about a lot every time of content, such as news, documents, and articles. Is a practical example of challenges and solutions. Then we will review the system design where we experience a lot of components, a lot of services like EC2, Route 53, and others. Finally, we will conclude our exploration with valuable lessons learned throughout this process. We will discover EC2 or scaling group practice and also additional best practice for databases for design and optimal application. Okay, first, the case study. Okay, on our case study, I'm going to talk about a CMS. It's a content management software. You can see my class diagram. So this is a class diagram where it's important for you to detail that there are many components. Key components has users, topics, news, documents, and areas, for example. And the basic workflow is that the author grades contents and send it for approval. Then the content is edited and the editor check for grammar and spelling. Then the content goes to the approval process. The approval process is a review of the content in order to check the required standards and guidelines. Then if the content is acceptable, it is sent back for the author for recommendations enough, it goes ahead and proceed with the next step. And the scheduling process is a process where once the content is approved, it is scheduled for publication. It can also be scheduled for expiration. That means that it will no be longer able after some specific date or time. Finally, it is published on the internet for readers to access. Okay, now you can see the deployment diagram. In the deployment diagram, illustrates the distribution of the application components in their physical layout on processing nodes. So the processing nodes consist of three main components as the front end, back end, and database. In the front end is the user client. The user client was made with Angular So the communication between the components is by HTTP protocol. Then you can see the API web server that was made on Node.js Express. And also the last component is the database server. Is to establish a connection to the MySQL database from Node.js. Now the system design. Okay, our first approach in the system design was using only EC2 server. It is no fault tolerance because it's the only one server, but you can see an MVP in order to test our application. So you can notice here that you can choose between different kind of EC2 instance. For example, the A1. The A1 is appropriate for ARM processors, so especially applications that use that kind of processors. The T2 is so common, it's a teeny data server, for example, but also for web server, but it's so popular in the Amazon. So in the whole T family is so popular. The main characteristic of T2 is that it's burstable. Burstable means that you can use for CPU, for example, requirements who are variable requirements of CPU users without a negative impact that is appropriate for that kind of use. And the M4 is more robust. It's a general purpose machine that provides a balance between CPU, memory, and network performance that is appropriate also for a more robust application, but has more power of compute and also memory capacity. At the end, the choice between any of these kind of machine, because there are many others, depends of your project, of your specific requirements, because each project has a different characteristic, a different workload. Okay, and here you can see our next step. Our next step was adding a necessary component as Route 53. Route 53 provides a scalable and secure availability for DNS servers. A DNS is a domain name server which is necessary because it facilitates access to your web through a custom domain name. So in addition, other nice characteristic here in AWS is that you can configure the IP address of your web application to match the location of your user in order to improve performance. Also, Route 53 is like a magical guide that helps people to find your website faster by configuring its address to match their location. It's like living next door to each other on the internet. It's a nice service for DNS. Uh, After some time, we're analyzing some decision about scaling because scaling was a good choice here. Initially, you can scale vertically. Vertically means that you can add more memory and more power of compute to your current server. Remember that we started with only one server, but reach a moment where it's impossible to increase more memory to only one server, and it explodes. So that is one reason the horizontal scaling is better than vertical, because scaling vertical means that you add more and more to only one server, but also is limited in hardware constraints. And the main problem here is a single point of failure, because we are running only one machine. If the machine fails the entire system. This is the real problem. To solve the situation, we scale horizontal by adding elastic load balancer and auto scaling group. Both working together was nice to add us to allows availability and increasing scalability. So remember here that adding these two key components as our scaling group and application load balancer increases the scalability and availability of application because it enables to distribute compute between different EC2 instances in different availability zones, increasing the fault tolerance of application. That was a nice characteristic here. And then after some time, we were facing problems with database MySQL. Remember that database has to face many queries, many requests. So sometimes it faces problems of latency. So we add a new component, which is Elasticache for Redis. So initially we use Redis to store frequently accessed information like areas, news, and articles. So having a in-memory data store provides a low latency and also has a real-time application. So storing data in memory instead the database decreases the response time and improves application speed. So having that frequently accessed information in memory was really nice for application. Okay. Also, another problem was the static information. Remember that our application has posts. Posts can have images, videos, and attachment. Any kind of attachment the authors can add to his publications. So we decided to move that kind of information to strip buckets, also working together with a CDM. So basically, S3 buckets is to store a lot of information, and the cloud form is to coordinate that kind of information. So having that static information on EC2 instance was inefficient because the web service has to carry a lot of multimedia content. But also using a CDN like CloudFront for multimedia content allow us to prioritize main tasks. For example, now the EC2 instance are focused on handling dynamic content, processing requests, and executing business logic, resulting in a better performance, better and faster content delivery, and improved scalability. Really, one solution such as a CDN has CloudFront is because it, working together with S3 buckets, replicates and caches content from S3 buckets in many data centers around the world. The data centers are locations are close to the users because they are based on geographic proximity. It selects the closest data centers to serve the end user. Okay, after some time, we were asked to add a new functionality of searching like Google. Uh, they decided to look for information of news, but looking for information on text. Yes, it's like when you are Google, you look information based on you are typing, but you can type misspelling and Google finds information. That is the same functionality, but analyzing, we decided to move all information of tests of publications to Elasticsearch because MySQL was not appropriate to manage that kind of information. And Elasticsearch give us a better performance for searching because it's faster, allows also searching with misspellings. It was so nice. So another solution here was adding as sharding. Sharding, by example, the comments by region was also an additional improvement here. Okay, and in the final design, we incorporated the command and query responsibility segregation pattern along with the addition of a MySQL replica. CQRS separates the responsibilities of writing and reading operations for optimized performance and scalability. To improve the design, we created a replica for MySQL. This means that the main MySQL database is dedicated to only writing operations, while the read replica handles the read operations. This new setup allows us to improve performance as read queries can be redirected to the read replica, reducing the main database from additional load and read operations. Finally, I am going to talk about lessons learned. Okay, we have several lessons learned here, but we summarize a few. The first is the instance frequency. The instant frequency is when the auto-scaling group tracks information from the EC2 instance, but by default, it tracks information or metrics every 5 minutes. What's important is activating a daily tracking to 1 minute in order to have more fresh metrics, because AWS monitoring is a critical part of EC2 auto-scaling. So scaling events can depend on application and instance metrics. A 5 minutes frequency might be slow in response time, resulting on scaling based on all metrics data. So the 1 minute frequency is for additional charts, but it doesn't matter when you need scalability. This is a real good performance. Okay, another best practice was to review the health check. Initially, the health check is configured to receive information only from the EC2 instance. But as we are using also Elastic Load Balancer, we need to receive or take advantage of receiving information from Elastic Load Balancer also. You can activate it in the check button with is in red. So in that case, you can receive both from EC2 and from Elastic Load Balancer a health check. And additionally, in the bottom side, you can see a grace period. It applies only to new instance. So related to the previous slide, you can reduce here also to 1 minute in order to reduce the grace period also here. Okay, another so important thing is to analyze in detail how to scale. When you are testing, you can scale manually. Scaling manually means that you can set up the minimum, the maximum, and the desired capacity manually, but it's not real performance. When you go to the reality, you have to scale in 3 ways. The first is in a scheduled way, means that you schedule and set up a desired capacity to a specific date on and time. So you can also configure it by a dynamic way as based on demand. Based on demand, many times we configure it based on CPU users, for example. And the last one is in a predictive way. Predictive way combine dynamic plus a predictive way. And also here you need some criterion as, for example, deciding CPU users, for example. Yeah, you need some politics or some levels to review. For example, when you are scheduling it, you decide, for example, next morning at 1 p.m., I want to have 10 instances running. Yes, but the same Monday at 11 p.m., I only need 2 instances running. You can set up based on a date and a time, exactly. But when you are setting up by dynamic way, you need to decide exactly some metric. In that case, many times we use the CPU users. For example, we set that 30% of users in order to increase the numbers of instances running. And when it reaches that level, it increases the numbers of instances running. Yes, but in a predictive way, we need also the same level of 30% of the same metric. But in that case, as it adds based on historical data, When it is reaching at 35%, it will increase faster and anticipate the 30% because it's so close. It knows that it's close to the level and increase faster than in a dynamic way. But the predictive way of predictive scaling is useful when your demand changes quickly because it can anticipate better. Also, when you issue to instance, need more time to start. For example, if you have an instance that start to running 5 minutes, it will be better because it can add faster than a dynamic way. Also, remember that when you set up a predictive way, it is not functioning immediately, so it will not scale until it is turned down. In the toggle, you can see a toggle button here where you can activate it. Predictive scaling limits before it can start. A minimal, it requires 25 hours of data to activate predictions. So as it uses historical data to forecast and predict and scale capacity, so it's important to know that you need at least 24 hours of learning or collecting data in order to enter to scale in reality. So another lessons learned was to notifications because notifications are so important in many aspects. But why should we have notifications? It is important to have notification in AWS for our scaling groups because they keep you informed about important events and changes in your environment. If you don't have notifications set up, you might miss critical information such as attack or a sudden increase in the number of instances, for example. So notification allows you to receive real-time alerts when relevant events occur, like changes in instance capacity, instant failure, or scaling events. This gives you the opportunity to quickly take action to mitigate any issue or respond to a sudden change in workload. So by setting notifications, you will stay updated on any anomalies or a significant event in your auto scaling environment. That enables you to make informed and to take action, to take decisions, ensuring your system is functioning optimally and securely. Another decision we faced was about RDS versus Aurora. As you notice, we used MySQL, but there are two options in AWS using Aurora versus RDS. So basically, Aurora is better than RDS because RDS provision up to 5 replicas, but Aurora allows 15. So Aurora scales faster, has this ability to replicate quickly, and RDS is slower compared to Aurora. So please choose Aurora always for MySQL. Okay, another important topic here to use is replication plus sharding. Please use both together. As replication, when you have a pizza, for example, replication, you are making a copy of a complete pizza on each server, for example. But the other hand is the fragmentation or sharding, is when you have or you are sending pizza slices to several different replica sets. But if you combine all the slices, you have access to all the pizza. It's the same approach here. It's better to combine replication plus sharding. But why sharding? Sharding is not easy, but it's important. If you have reached, for example, the limits of the MySQL table on AWS is 16 terabytes, in terms of performance, it means that your workload and data size has grown. It reaches a point where it's impossible to grow and cannot handle it efficiently. Uh, One common solution in this situation is to implement database sharding, because sharding involves dividing your database into small fragments called shards and distributing the data among them. Each shard is an independent database that you can reside in a different server. By distributing the data across multiple shards, you can achieve better scalability and performance. Each shard handles a specific portion of the workload, allowing queries and transactions to execute more quickly and efficiently. So basically, sharding is complex. Yes, it's not easy. It adds complexity to the application. But it's important to note that database sharding requires careful design and planning. As it's not easy, it involves dealing with data fragmentation and coordinating between different shards. However, when you implement it correctly, sharding can overcome the performance limits of MySQL tables and enables efficient management of large volumes of workload. That is a good idea here to use replication and fragmentation, that is a fragmented cluster. And that is all my presentation. Thank you for your patience.
Thank you so much, Jhon. I think it was such a very interesting presentation. I really enjoyed the part of the lessons learned. I think that that will be like a crucial manual for all the people who are using AWS for those purposes. I'm pretty sure that also that the audience will let comments or will leave comments and questions. And if you are thinking to do it, please do it, because as you know, Jhon will be chatting and interacting using the live chat, and we are allowed for this edition. And I think that's it. That's it, Jhon. I would like to thank you one more time for your time, for this kind of content, this kind of technical, really technical content. And I'm really happy to have you here. And I hope to see you in following editions of this great project, the Global Dev Week. One last reminder for the audience, please don't forget to follow us on our social media appearing at this moment on the screen. And also don't forget that if you want to watch the next session starting at this moment, you need to return to the official website of the Dev Week in order that you can watch the full agenda and select the next session. This is all for my side. Thank you so much, Jhon. Thank you for your time. See you later.
See you. Thank you.